Hello. Well, I'm going to explain this. Truss. We have these dimensions. The horizontal distance between vertical bars is 4, and the vertical distance between these points, it's always 3. It's 3, 3, and 3. And so the total dimension is 9 by 24. Okay, so first we have to calculate the reactions. So there's a reaction here, AX, AY, at this point, point A, and then we have this reaction here. We have this reaction here, GY, going up. And these are the external forces. At each point, we have 10, a load of 10, the blue one. We have a red horizontal force, 11. And then here we have vertical ones, 12. Okay, so we have 3 kind of forces, 10 going down, 11 going left, and 12 going down, but at these points. So the first thing we have to calculate these 3 reactions. There's a very simple one, which is the horizontal. And we only have to add up these 3 forces, 1, 2, and 3. So AX equals 3 times 11 equals 33. So that's pretty straightforward. Now the vertical equilibrium. And we have 2 forces going up, these 2 reactions, AY and GY. And what goes down, all these forces go down. So it's 1, 2, 3, 4, 5 forces times 10. So that's why here we have 5 times 10. And here we have 1, 2, 3, 4, 5 times 12. Okay, so this is what goes down. So that's the equilibrium, the vertical equilibrium equation. we get AX, but we don't have AY or GY. So we have to solve the moments, or to create this equation, the moment equation, a rotation about this point, about point A. And first, we need to understand what is clockwise. So all the vertical forces, if we apply this force here, we will have a rotation in this direction. So that's clockwise. So every vertical force will have that effect. So on the clockwise part of the equation, we have 50 times 12 and 60 times 12. What does it mean? Well, it means that all these forces, when we have these forces, they are all the same and they are symmetrical. So we can make this. So the effect of these forces is like a big force, and the value of this one is 50. So why is that? Because we have 5 forces, 1, 2, 3, 4, 5 times 10. So the total value is 50. And where's the line of action? It's the line of symmetry between all these forces. So if this is symmetrical, so the symmetry line is this one. So that's why the distance is this. And what is the distance between this force, the line, the action line of this force, and that point? Well, the action line is this vertical line, and the point is this. So the distance is 12. Okay, so we have 4, 1, 2, 3, times 3, 4 times 3, it's 12. Okay, so we can summarize these 5 forces, or the resultant of these 5 forces is one force. The value of the force is 5 times each of them, so 50. And the action line is the symmetry, is the line of symmetry between all these forces. So it's here. and the distance between this action line and this point is 12. The same thing happens with this. What's the resultant of these 5 forces going down? So we have 12 times 5, 60. And the distance, it's 60 times 12 because the action line is the same. So the distance between the action line and this point, it has to be 12. Okay, so, and the effect of these two forces is a clockwise movement of the structure about this point. So it's 50 times 12, it's 50, the value of the force, times 12, the distance, plus 60, the value of this resultant, times 12. So this is the effect of the clockwise, or this is, yeah, so this is the clockwise movement. And now what is the counterclockwise? So Gy, if we apply this force, goes up, the rotation of this truss would be in this direction. So that's counterclockwise. And then we have the horizontal forces. So if each horizontal force we try to move the structure, the rotation will be in this direction. So it's counterclockwise. In this part of the equation, I have, this is pretty straightforward because we have Jy times the distance, and the distance is 24. The distance between the action line of this force and this point is 24. And what about this? Okay, so first we need the resultant. So if there are 3 forces going in the same direction, the resultant is the sum of the 3 forces. And what is the action line? The action line, it's the symmetry. So where is the symmetrical line? It's here. It's at this point. Okay. So the resultant of these 3 forces is a force that it's the sum of the 3 forces, 11, 11, and 11, total 33. And the distance of this action line and that point, what is? So we have to extend this line. Okay, so we extend the action line, and then we need a perpendicular line from point A to this action line. And then we have to take this dimension. This is 6. Okay, so it's 3 plus 3. So the total 6. So the effect of this force, 11 times 3 plus 11 times 6 plus 11 times 9 is the same as 33 times 6. So that's the explanation of that. So in this moment, in the counterclockwise part of the equation, or side of the equation, we have 11. Sorry, this is not 11. It's the resultant, 33 times 6. Okay, it could be 11 times 3 plus 11 times 6 plus 11 times 9. But the resultant is 33 times 6. And then plus Gy times 24. Okay, so we solve this and we get Gy. Now, if I use the Excel file, because I want to make it, so F1 is 10, F2 is 11, F3 is 12. So the reactions are 33, 60, 63.25, and 46.75. So now I'm going to Gy, it's 46.75. And here on this one, AY would be 46.75 because it's Gy negative, because it goes to the other side of the equation as a negative number, and then plus 50, 5 times 10, plus 60. Okay, so this is gy negative because it goes to the other side of the equation, and ay, and that will be ay 63.25. Here you go. So with these equations, we have reactions. So this is the first thing we have to do when we have to calculate this. The first thing we have to do is to look at the external forces, and then we have these three equations: vertical, horizontal, and moment, and then we have to calculate the reactions. Now we have to go point by point, and now we have to calculate the forces on all the bars that we have here. So it will be AB and AL. That would be the easiest part. So let's do it now. So we have a force going up. That would be a AY, it's 63.25. Okay, so that's AY. $63.25, and it goes up. So that goes up. Okay. The second one is AX. AX is 33. 33 going in the other direction. Okay. And that is 33. 33. And there are two bars here. So this one and that one. The first thing, we have to calculate this angle. So I don't know the length of this. That. So I don't know the length, and I don't know the angle. So if we are working with this, we can go to the angle dimension, and we can take that, and it's 36.87. How can I make sure that this angle is 36.7? Because in this triangle, this is 4, this is 4, and the height is 3. Okay, so the tangent of this angle is 3 divided by 4. And the angle is arctangent of 3 divided by 4. If I use the calculator, first I need 3 divided by 4.75, and then I need the arctangent, this one. So it's 36.86 or 87. Okay, so that's the angle. If I'm doing the, if we're using the graphics, we can just measure the angle. Okay, so in this case we have AB and AL. So that would be AB and AL. And now we have to make a guess about the directions of this. So here we have something going up. So most likely AB has to go down. So I'm going to make the assumption that AB is going down. And if this goes down and this goes here, yeah, I think I'm going to make the assumption that this AL will go in this direction. Okay. Like that. No, I think I'm going to make the assumption that it's the other way around. Like this, okay? Why is that? Well, because this has to be, I think this is going to be greater than this one, so that will go in this direction. Okay, so what are the equations now? The equations in the vertical, we can calculate, because in the vertical, we only have the vertical component of AB. So the vertical is pretty straightforward. So the vertical equation, we have 63.25 going up, 63.25. That equals AB sine 36.87. So that goes down. Then AB equals 63.25. This goes down, divides this. So AB equals 63.25 divided by sine of this angle. And how much is that? So again, we have 36.87 sine. So this is 0.6. So 63.25 divided by 0.6. This is 105.4. 5.4. If I go to the Excel file, it should be the same, 105.4. Compression, so on this Excel file, everything that it's in compression, it's red, and what is tension, it will be green. So this is like that. And then the horizontal, I have 33. I have AL going in this direction, going right, and then I have AB cosine the angle going right. So the horizontal equation is 33 plus AL. And now I have AB. AB is 105.4 cosine 36.87. So that's the equation. So AL equals 105 cosine 36.7, and this 33 positive here goes to the other side as a negative number, minus 33. And that will be 36.87. Now calculator, 36.87 cosine times 105.4 minus 33. So that would be 51.3, 51.3, yeah, 0.32, it's 0.33, okay. So 51.3. So AL is 51.3. Okay, so now the question, can I do, there are different ways to do that. First, I can solve the equations, I can use that Excel file, or I can do it by drawing things. That's my favorite method. So if I do that, if I create this, so if I analyze this point at the end, there should be a polygon and there should be a closed polygon. So if I start with AX, then with AY, then with this force, and then with that force, we have to start with one point and we will end up at the same point using the same angle, of course. So let's do it. First, we have to, these two forces. Okay, so the first one would be 33. And the order is important. If I start with this force, the second would be this one, the third would be that one, and the fourth would be that one. So that's the first. Then the second is the vertical one. So I go in this direction up. And now the third is another horizontal force. And finally, the fourth will be here. Okay. So I know that I have to start and finish at point A. Okay, so now what I know is that we have this vertical, we have this horizontal, and I know that the next one, it's this horizontal here. So the action line of this force, it's going to be like this. And I'm going to select, because that's the action line. Okay, so I know that the following bar, it's going to be horizontal. It can be left, right, I don't know yet. But what I know is that the last one has to finish at this point. Okay. So what has to happen here? So I have the first one, 33, the second one, 63.25. So the third one has to go right, and the fourth one has to close the gaps, has to close the polygon. It has to arrive at the same point, point A. So if I chamfer this and that, now this force it's going to go in that direction, and that force is going to go in that direction. So that would be AL, it's the horizontal one, and then AB is the tilted one with that angle. If I take the dimension now, this is 51.3, and this has to be 105.4. Yeah. Okay, so that's great because you can use any software like this, or you can use the drawing with rulers to calculate the angle, and you should get exactly the same dimensions. So I'm going to do the same at point B. Okay, so at point B, what do I get? This is point A, and this is point B. So at point B, I have a force, a vertical force going down, and this is 10. Okay, so now I need a force here, and it has to be 10. So that's the force, it's only 10, so it's small. If I create the arrowhead here, it has to go down because it goes down. Okay, so that force is 10. Now, the following is AB. I already have AB. And AB at this point, it goes in that direction. Okay, so at point A, AB goes in that direction. But at point B, it has to go in a different direction. And how comes? Okay, so look at this. This is AB, and this is point A. And this is point B. Okay, so I know that some of you don't get it yet. If I'm analyzing point A in this bar, we have in this direction. But at point B, if we have the same direction, if the arrow goes in this direction, then the bar will move. So we don't want that to happen. So if I analyze what happens in point B, the arrow has to go in the other direction so that we have equilibrium. Okay, so if we're analyzing point A, the arrow goes down. But if I'm analyzing point B, the arrow has to go up, because if I analyze the whole bar, there should be equilibrium, because if both arrows are pointing at the same direction, the bar will move. So that's why at point B, I need to select this one. Okay, so AB will go in this direction, and the value of this one, it's going to be 105.42, the same. Okay, now we have two unknowns, this one and that one. So let's go to the equilibrium. So the first, we have 1, 2, then 3 and 4. So the first one goes down. So if I'm at point B, the first line goes down 10, because that's the external force, go down. The second one is this one, going up. Copy this one too. Okay, so the first one is 10 going down. The second is this one going up. And then we have one vertical and one with the same tilt. So how can we, if we have a vertical line and I have another line and they both have to meet at this point, what can I do? Okay, so here I know that I have a vertical one. I'm going to use the dot line. And I don't know yet if it's going to go up or down. But then the other one, it has to be a force that ends up at this point, at point B. And I know the direction. Okay, so I can copy this direction. Or I can copy this. And I'm going to make it dot line. Okay, so if I want to close this polygon, the only thing I can do, okay, so look at this, we have 10, then we have this one, AB, going up, then we have the vertical one, and finally we have the other one. So that one is gonna be this one, having this intersection here, and the other one, I'm going to chamfer this and that. So the arrow here has to go up. And now that one This has to go down. Okay, so that would be 10. And that one would be 105.42. Okay, so at this point, this is CD. This one is BC, sorry. And this one is BL. So the one going down or going up, sorry, it's BL. Okay, so that's what happens at point B. Now, the next one would be point L, because I can't go to point C because at point C we have a lot of unknowns. I don't know this one, I don't know this one, so there are 4 unknowns. So I have to go first to point L. And then when I get point L, I can go here. And when I'm here, I can go to this direction. Okay, so at point L, what do I get? I have a force 12 going down. Then I have AL. I have already calculated AL. I have already calculated BL. And I have 2 unknowns. So BL at point B, BL is this one. Going up. BL equals 10. Okay. And this one is BC. So BC will be 105.4 going down. Okay, so this is what I got in point B. So now BL at point B goes up. So at point L, it has to go down. So I'm going to analyze point L now. So at point L, what do I have? I have AL going in this direction. That's AL. No, sorry, AL is this one. It's the 51.3. That's AL. Now, AL at point B, I have this going down. It's 12. So I go 12 down with the arrow here going down. Okay, so this is 51.33. This one is 12. I've got this one here. This is a BL going up. This is 10. It goes up in at point B. So here it has to go down. Okay, so that would be 10. And now I have two unknowns. Okay, so now let's analyze this point. I have 10, 51.3, then 12, and then this one and that one. So the first one, 10, goes down. The second one, this one, go in this direction. And okay, I'm making a mistake because, yep, if this AL at point A goes in that direction, so at point A goes in that direction, so at point L it goes the other way around. So the following, I have 10. The following line is this one. Then the following one is 12 going down. And now I have two lines. I have a horizontal one. So from this point, it has to go horizontally. So this is a dot line because I don't know the direction yet. And then this one, it has to close the polygon. So if I started at point L here, so it has to go in this direction because this is the starting point, point L. L is here. Okay, so at point L, we have 10 going down, 10 going down, then 51.3 going right, then 12 going down. And now I have this and that. So I have to chamfer this and this. And if I want to close the gap, I have to chamfer again this and that. So that will be the closed polygon. So first go down, the first force goes down, the second goes left, the third goes down. So this bar is going to go in this direction. Okay, so this has to go in this direction, and that bar will be L, A, B, C, L, LK. Okay, so that point here is LK. So that bar will be LK. And the other one will be LC. Okay, and LC has to go up. Okay, so now we can make this L key and LC like that. So what is LC and L key? Dimensions. This is 26.44 and this is 36.66. 67. So LK, let's check this here. LK, it's 36.67. LC, it's 26.4. So we have exactly the same values. I know, well, I told you that I find this easier because I tend to draw things. Uh, we can always do the maths to see if it's the same. And now the nightmare. The nightmare is point C. Can we go to point C right now? We have, no, we can't because we have now this one. This is BC. We do have BC. We have LC. We do have it, but we don't have KC. And then here we have three unknowns. Okay, so the next point has to be point K. So at point K, we have point K. I told you that it's going to be very straightforward because this is, if we analyze that point, the vertical equilibrium. So this one, KC, it's going to be 12 going up. If I have L key, so the next one is going to be the same as L key, or L K, sorry, going in the other direction. Um, okay, so let's do it. So first LK. If we're at point K, now LK has to go like this. So KJ, that's J. KJ is the same as LK, but in the other direction. EKJ. And now we have this one going down, 12. Okay, because at point K, we have 12 going down. So that's 12 going down. And now the same. It's going to be 12 going up. So this is KJ, and that will be KC. So KC is this one. KC. KJ is the same as this one, and KC is the same as the other one. So now we can go to point C. Okay, so I'm going to copy all these because these are all the things affecting point C. Point C. External force at point C, we have 10 going down. So I'm going to do the right scale. So this is 10 going down. So at point C, we have 10 going down. Now, the next one is BC. So if BC goes in this direction at point B, at point C, it has to go in the other direction. So that goes in this direction. Then we have LC. So if LC, if we are at point L, if LC goes this way at point L, at point C, it has to go in the other direction. Okay, so now we have the right dimension. This is 10, this is 105 point something. This is LC, it's 26.44. Now we have this one. This one is KC. So KC was 12. KC was 12. If at point K it goes up, at point C it has to go down. Okay. And now we have these two bars. We have only two unknowns. So now let's start the polygon. So we start at point C. So I have to leave the two unknowns at the end. So I have to start by this one, 1, 2, 3, 4, and then we have two unknowns. So point C, it's going to be at the beginning of this polygon. So C, that goes down. Then this one goes up. Then the following one is this one. This goes down. Then we have another one going down. It's this one. Copy. It goes down. And now we have the next one has this direction. We don't know if up or down. Let's make it dot. And the last one has that direction and it has to arrive at this point. So to here, and this has to be a dotted line. Okay, so that's the line, the first, then the second, then the third, then the fourth. So if I want to go to this point, I have to go this way, and then I have to go that way. So this one has to be this point. So this has to go up. Right here. And this one has to go down. So I'm going to make this a different color. And that one has to go down. And okay. So this tilted bar is CJ. And that bar is C. I think that's point D. So that bar is dimensions 68.7 and 26.44. So let's look at CD. And CJ, it's 35. Yeah, so I think there's a mistake here. I think I made the mistake in the Excel file, so I have to fix it. Okay, so I find I'm doing this to check whether my Excel file is right or wrong. I did this yesterday, and I think they have the wrong numbers. So I'm going to fix it now. But I like the graphic method because it's very easy. If you know what you are doing, you don't have to calculate anything. You only have to draw things with the right dimension.